Today let me explain to you the method of doing a different type of differential equation. So it's solve d squared x squared d squared minus xd plus 4 of y is equal to x squared sine log x. So this is a problem. I'll take this. So this is a problem in which you find that this is a homogeneous. This is x squared, and what is this d? D is nothing but your d by dx. Now this is a second order differential equation, and here the coefficients are variable coefficients. X happens to be the variable there, which happens to be the coefficient of the terms here. Now how to solve this? This is a question. See, I cannot solve, it will be difficult for us to solve as it is. So what we do is we change the variable, that is x, the independent variable, to some other variable and get hold of this d squared values, second order different derivative and this first order derivative, bring them here, and then so that it will be a second order differential equation with constant coefficients, the solution of which is easy to find. So our job is now to find given that is a change of variable. So I'll write it here. Let x be equal to e to the power of z. I'll take x is equal to e to the power of z. So this will tell you that it is easily, you take log on both sides with base e, so that this will become as what? Base a is log of x to the base e is understood. So it is z log e to the base e means z. So log of x is equal to z. So differentiate with respect to x on both sides. So this will give you what? 1 by x is equal to dz by dx. So this is what we will get. Now I will write dy by dx is equal to d by dx of dy by dx into, I will write dy by dz and dz by dx. The value is not altered. Dy by dz into d by dz by dx. So that because of this change of variable x to z, I am going to convert that by this differential equation in terms of the independent variable z. Z will happen to be the independent variable, change of independent variable. So 1 by x is equal to dz by dx. Therefore, this implies that dy by dx is equal to, what is dz by dx? It is 1 by x into dy by dz, which implies that x into dy by dx is equal to dz by dx. So you see that in the place of this x into dy by dx, I can substitute dz by dx. You happen to see that the coefficient is a constant. So you call this as your 2. Now let me find what is my d squared y by dx squared. So this can be written as d by dx of dy by dx, and this can be written as d by dz into dy by dx into dz by dx. Now you see that dz and dz will get cancelled, giving you this. My idea is to change it to a new independent variable z. That is only I think. So this is equal to, so this is d by dz. Now differentiate this. This is d by dz into dy by dx. What is the dy by dx here? dy by dx is equal to here 1 by x into dy by dz into dz by dx. Now differentiate with respect to z now. This is minus 1 by x square dx by dz into dy by dz. I use the product form. Differentiate this with respect to z. Keep this as it is. And dy by d, that is differentiate 1 by x with respect to z into dy by dz. And 1 by x into plus 1 by x into differentiate this dy by dz with respect to d by. So what is that you'll get? D squared y by dz squared. This must be multiplied by dz by dx. Product form, differentiate with respect to z. So 1 by x, when you differentiate, it is minus 1 by x squared into dx by dz into dy by dz you'll get. So what is that you'll get? Bring this inside. So it is dz by dx, it is dx by dz. So you'll get it as minus 1 by x squared into dy by dz. And when you bring this inside, so it is plus 1 by x. What is the value of dz by dx? Dz by dx is what? Your dz by dx. Here, dz by dx is 1 by x. So into 1 by x into d squared y by dz squared. So this will be equal to, I'll write here 1 by x squared into, it is minus dy by dz plus d squared y by dz squared. So from this, so what is that we get? D squared y by dx squared is equal to 1 by x squared into this. Now cross multiply. So what is that you will get here? So if you do the cross multiplication, you will get, so if you do the cross multiplication, you will get x squared into d squared y by dx squared is equal to minus dy by dz plus d squared y by dz squared. So what is that we are having? For the first x into dy by dx, we had dz by dx. For x squared into d squared y by dx squared, we have minus dy by dz and d squared y by dz squared. Call this as your 3. Now, so x into dy by dx is here. X squared into d squared y by dx squared is here. Substitute the values. You see that here the coefficients are constants. Here it is variable. Now we are able to change the variable coefficient to constant coefficients. Now our job is easy to do. Now I'll write, therefore 1 becomes, so having this in this, I'll write it here. So 1 becomes, substitute the values. So 1 becomes, see x squared into this will be what? X squared and d squared y will be equal to your d squared y by dz squared minus dy by dz minus x dy. It is minus x into dy will be equal to minus, it is again, it is dy by dz. We have found the value of minus x dy as what? Minus dy by dz plus 4y will be equal to, see from this you can write this x squared is equal to e to the power of 2z. And here you see that log x is equal to z. Therefore, so we have got log x is equal to z and your x squared is e to the power of z. So on the right hand side, in the place of x squared you can write e to the power of 2z, and in this place of sine log x will be equal to z. So what is that we have got here? So I will explain once. So we have used the transformation x is equal to e to the power of z, and using that we will be able to get the value of x dy by dx as what? It is dy by dz, and x squared d squared y, that is d squared y by dx squared as what? Here we have got minus dy by dz plus d squared y by dz squared. Substitute them here, and on the right hand side you have taken x is equal to e to the power of z, so x squared will be equal to e to the power of 2z, and log x is equal to z, so substitute the values here so that you will get the new transformed differential equation is this, and this is, you find that this is a y is dependent variable on z, and that this is a differential equation with constant coefficients. It is now easy for us to solve this differential equation. Now let me solve this, and after getting the final result, change it to old variables. You will get the answer for that. Now let me do that. Now from this, what is, see, I have already taught you this. So what is that you'll have? So this can be written as what? D squared y by dz squared minus 2 into dy by dz plus 4y is equal to e to the power of 2z into sin z. Now, so what is your y? Y will be equal to complementary function plus particular integral. See, let us to find complementary function. What is your auxiliary equation? Your auxiliary equation is m squared minus 2m plus 4 is equal to 0. So what is your m? So this is a quadratic equation. Minus b means 2, plus or minus root of b squared is 4, minus 4ac is how much? 16 divided by 2a. So this gives you what? So this is equal to 2 plus or minus, this is minus 12. So it is an imaginary number. 12 is what? It is 4 into 3. 4 into 3 means what? You will get 2 root 3 divided by 2. Because this is an minus 12 will be an imaginary number, therefore I put I. And 12 can be written as 4 into 3. And square root of 4 is 2. That is why I have taken this 2 outside. So 2 plus or minus I 2 root 3. So this gives you 1 plus or minus I root 3. Imaginary roots occur in pairs. So m is equal to 1 plus I root 3, and m, that is what? M is equal to 1 plus I root 3, and m is equal to 1 minus I root 3. So these are the two roots. Therefore, complementary function is C1. Here it is not C1. See, what is that? If they are imaginary roots, then e to the power of, what is in the place of, real number? It is 1. 1 into z within brackets C1 into cos root 3 into z plus C2 into sin root 3 into z. Because your independent variable here is what? Z. Therefore, this is. So, call this as your E. Now, we are able to get the complementary function. Find the particular integral, join them, you will get the answer. Now, what is your particular integral? I will write it here. What is your particular integral? See, particular integral is equal to what? It is e to the power of, it is e to the power of 2z into sin z divided by, what do you get here? It is d squared, see here, d squared minus 2d plus 4. That is, integration of the numerator should be carried out with respect to d squared minus 2d plus 4. Now, here this is a combination of two functions. One is exponential and another is a circular function. So, here the best method of doing is go for writing this as imaginary part of e to the power of 2z into e to the power of I z divided by d squared minus 2d plus 4. Can you catch this, what I am writing? See, because what is this e to the power, using De Moivre's theorem, you can write cos z plus I sin z. If you want to take the imaginary part, here sin z will come. So you can the purpose of doing this is bringing it to e to the power of something which will be easy for us to integrate. Nothing more than that. Because keeping this sin z, keeping it as it, maybe we may be able to do, but it will be difficult. But if you use this method of doing it, it will be just easy for us to do, because you are going to replace this d by the coefficient of e. The coefficient of z here. What I mean is here, say I will put it here. So this is equal to imaginary part of e to the power of z, and you write it as 2 plus I. It is 2 plus I. See, 2 z into 2 plus I. Z into 2 plus I divided by d squared minus 2d plus 4. So you see that now if you want to integrate this, simply replace or substitute in the place of d 2 plus I and get the answer. It is very simple. Okay, that is why we are using this imaginary part of e to the power of I, imaginary part of e to the power of iz, which will give you sin z. Now, so now what is that you will do? Now it is easy to do now. So replace this. So this particular integral will be equal to, it is e to the imaginary part of e to the power of z of 2 plus I divided by, wherever d comes you substitute d 2 plus I. So this will be 2 plus I whole square minus 2 into 2 plus I and plus 4. So this will be equal to what? So this will be, you can solve it in any way you want. Here 2 plus I, you take that and you will get, see what is that you will get? Here I will simply write it as imaginary part e to the power of z of 2 plus I divided by, see it is 2 is 4 plus 4i minus 1, because I squared is minus 1 minus, see it is 2 plus I, will write it here, 2 into 2 plus I, it is minus 4 minus 2i plus 4. So 2 squared is 4, 4i minus 1 minus 4 minus 2i plus 4. So this one minus 4 plus 4 goes off. It is 4i minus 2i is 2i. So what is that you will get? Imaginary part of e to the power of z of 2 plus I divided by, see 4i minus this is 2i and minus 1 this is plus 3. So that's all. So you see that here I should get rid of this. Do never keep this I at the bottom. Just multiply by its conjugate, so that you will get rid of the I value at the denominator. So you're using that, we will be able to get rid of this I in the denominator. So what I will do here is that, see further I will do like this. So this is equal to imaginary part of 2 minus 3 into e to the power of z into 2 plus I divided by 2i minus 3 into 2i plus 3. Oh, this is, sorry, this is conjugate, you have to multiply. See, this is 3, this is multiplied by 3 minus 2i divided by 3 minus 2i into 3 plus 2i into e to the power of z into 2 plus I. The conjugate, this you can write it as 3 plus 2i. Yeah? For your understanding, I will write this as 3 plus 2i. So if it is 3 plus 2i, its conjugate is 3 minus 2i. So multiply and divide it by the same quantity. So the value is not altered. Now you see that this is equal to 3 minus 2i into e to the power of z of 2 plus I. Okay, divided by 3 minus 2i into 3 plus 2i is 9 minus 2i into plus 2i is I into I squared is minus 1. So you will get what? It is plus 4 you will get. So you will get it is to be 13 here. So what is that? 3 into 3 is 9. This is minus 4. I squared is this. So you will get it as what? 13. So what is that you will get here now? So this is equal to, I will write here. See, I will write it here. This is equal to 3 minus 2i. It is nothing but what? This is equal to e to the power of 2z. I will write here. E to the power of 2z into e to the power of, you will get zi into e to the power of iz divided by 13. So this will be equal to 3 minus 2i divided by 13. I will write this as e to the power of 2z within brackets cos z plus I sin z. Cos z plus I sin z. Now you want here, you must write this imaginary part. Imaginary part, imaginary part. So if you want the imaginary part, you have to take only the terms involving this I. Terms involving this I. So what will you get here? So I will write it here. So your pi is equal to, you want the imaginary part. So what is that you will get here? See, e to the power of 2z, don't worry about that. E to the power of 2z by 30. Now you want 3 into sin z because I is inward. So 3 sin z. And here is minus 2i into this. So it is minus 2 cos z. Taking only the I values, that is what? Imaginary part, because I want the imaginary. So what is your particular integral? E to the power of 2z divided by 13 into within brackets 3 sin z minus 2 cos z. Now we have got the particular integral. Therefore, we have got the particular integral. Therefore, your solution is y is equal to complementary function plus particular integral. That is equal to, what is that? E to the power of z within brackets c1 cos root 3 of z plus c2 sin root 3 of z plus e to the power of 2z divided by 13 into 3 sin z minus 2 cos z. So this is the answer. But we are having it in terms of y and z, but it has to be given only in terms of y and x, because x is independent, y is dependent variable. Here we have changed to z, therefore z should be brought back to x form. So what is that you will have now? But we know that x is equal to e to the power of z, and therefore log x is equal to z. Now what is that you want here? E to the power of z. So e to the power of z means x. Now what is that you have? So x square will be equal to what? E to the power of 2z. X square will be equal to e to the power of 2z. And what is your ez? Log x. So wherever z comes, you put it as log x. And wherever this e to z comes, you put it as what? Here log x. So what is that you'll have? So you want e to the power of 2z means what is that you'll have? So e to the power of 2z will be equal to your x square. And now we will write the answer. Now what is that you'll have now? So y will be equal to e to the power of z. What the e to the power of z is? X. See, e to the power of z is x into c1 cos root 3. What is z? Z is log x plus c2 sin root 3 log x plus e to the power of 2z is x square into 3 divided by 13. 3 sin, what is z? Log x minus 2 cos, what is z? Log x So we have brought back to the old variable. So cos log x. So this is all the answer. Now